The largest diamond in the universe is not on Earth. It is not in any vault, or any crown, or any mine that human hands have ever dug. It is floating in deep space, roughly 48 light-years away, and it is a single diamond the size of the moon. Astronomers have estimated its weight at 10 billion trillion carats. Written out, that is a 10 followed by 34 zeros. Every diamond ever pulled from the ground on our entire planet, every stone in every museum, every ring on every hand, all of them put together, would not register as a single speck against it. The largest diamond ever found on Earth, the Cullinan, weighed around 3,000 carats. This one is not twice that, or 1,000 times that, or 1 billion times that. This diamond is not a gem, and it was never mined, because it is not really a diamond in the way we mean the word at all. It is a star. Or rather, it is the corpse of one, the crushed and crystallized heart of a dead sun, slowly cooling in the dark. It even has a name borrowed from a song. Astronomers call it Lucy. This is the story of the most valuable object in the known universe. An object worth a number that has no meaning. An object no one will ever reach or touch or sell. And it is the story of how that same fate is waiting, billions of years from now, for our own sun. Let us stay with that number for a moment, because it is almost impossible to hold in the mind. Diamonds on Earth are measured in carats, and a single carat is just 1/5 of a gram, a tiny thing. The most famous stones in history are counted in the hundreds. The Golden Jubilee, the largest cut and polished diamond in the world, is around 545 carats. The Cullinan, the largest rough diamond ever unearthed, was just over 3,000. These are the crown jewels of an entire species, the prizes of centuries of mining, and they are measured in numbers you could write on a single line. Lucy is measured in 10 billion trillion carats. To even approach that figure, take every diamond humanity has ever discovered, across every mine on every continent throughout all of history, and you would still fall so far short that the comparison stops being a comparison and becomes a kind of joke. If you tried to put a price on it, using the going rate for diamonds here on Earth, the number would run past quintillions and keep climbing until the digits simply lose all meaning. It is not an expensive object. It is an object that breaks the very idea of a price. To put that in some kind of perspective, the entire global diamond trade on Earth, every mine, every dealer, and every polished stone sold in a single year, is worth in the region of $100 billion. Set against Lucy, that colossal industry is not even a rounding error. And for anyone who has heard of the so-called trillion-dollar asteroids, the metal-rich rocks drifting through our own solar system that headlines love to value at $10 quintillion each, this one dead star reduces even those staggering figures to loose change. Lucy is not merely more valuable than any object on Earth. It is worth more than every object humanity has ever attached a number to, added together, many times over. But that price, like so many cosmic price tags, is a beautiful illusion. And for reasons we will come to, it is even more of an illusion than the $10 quintillion asteroids drifting closer to home. To understand why, we first have to understand what Lucy actually is, and to do that, we have to watch a star die. Lucy is not a planet, and it is not an asteroid. Its formal designation is BPM 37093, and it sits about 48 light-years from Earth in the direction of the constellation Centaurus. It is a white dwarf, which is one of the strangest kinds of object in the cosmos, and one of the most important, because a white dwarf is what a star like our sun becomes when it runs out of fuel and dies. The numbers that describe it are almost as staggering as its supposed value. Lucy contains about 1.1 times the entire mass of our sun, But all of that mass, more material than 360,000 Earths, is not spread across a vast glowing sphere. It has been crushed down into a ball only about 4,000 kilometers across, which makes this dead star very slightly larger than our own moon. A star heavier than the Sun, squeezed into the size of the moon. That crushing gives it a density almost beyond comprehension. Lucy is roughly 12 million times denser than the Earth beneath our feet. The gravity at its surface is just as merciless. Because so much mass is packed into so small a ball, the pull at the surface of Lucy is several million times stronger than the gravity we feel on Earth. A person who could somehow be placed upon it would not stand there for even an instant. They would be crushed flat by their own weight, flattened into something thinner than a sheet of paper before they ever knew what had happened. This is not a gemstone in any ordinary sense. It is a mountain of crystallized carbon with the mass of a sun. And to see how carbon becomes crystal on this scale, we have to look inside the death of a star. Every star is a balancing act. For most of its life, a star like the Sun fuses hydrogen into helium in its core, and the outward push of that nuclear fire holds up against the crushing inward pull of its own gravity. But the fuel does not last forever. When the hydrogen begins to run low, the star swells, and it starts to fuse heavier elements, turning helium into carbon and oxygen deep in its heart. Eventually, for a star of the Sun size, the fire simply cannot continue. The outer layers drift away into space in a glowing shell, and what remains is the exposed core, a dense ball of carbon and oxygen with no fuel left to burn. That naked, dying core is a white dwarf. It does not shine because it is fusing anything. It shines only because it is still holding the leftover heat of its former life. And across billions of years, very slowly, it cools. And this is where the diamond is born. As a white dwarf cools, the carbon inside it does not stay a formless, churning fluid. Below a certain temperature, under that immense pressure, the carbon atoms begin to lock into an ordered, repeating structure, a crystal lattice. Carbon, arranged into a crystal lattice, is the exact thing we call diamond. The core of the dead star crystallizes from the inside out. And studies of Lucy suggest that as much as 90% of its enormous mass may already have turned to crystal. It is not that Lucy contains a diamond. Lucy, very nearly in its entirety, has become one. This process is astonishingly slow. It unfolds not across years or centuries, but across billions of years, as the dead star bleeds its heat into the cold of space 1 degree at a time. Lucy has been cooling and hardening for an immense stretch of cosmic history already, and only now, heavy enough at over 1 solar mass and finally cool enough at its core, has the crystal truly taken hold. It is a jewel being forged in the slowest furnace that exists, the fading warmth of a corpse. Now comes the question that should stop us in our tracks. Lucy is 48 light-years away. No spacecraft has been anywhere near it, and no telescope can see inside a star. So how could anyone possibly claim to know that the heart of this distant object has frozen into crystal? The answer is one of the most elegant tricks in all of astronomy. Lucy is not a steady, silent star. It is a pulsating one, a type known as a variable star, and it rings very slightly like a struck bell, brightening and dimming in a rhythm that lasts several minutes. Those pulsations are sound waves moving through the body of the star, and crucially, the way they move depends on what the inside of the star is made of. A liquid interior rings one way, a solid, crystallized interior rings another. By listening carefully to Lucy's rhythm, a technique called astroseismology, astronomers can effectively map the inside of a star they can never visit. In the middle of the 2000s, a team led by the astronomer Travis Metcalf used exactly this method to confirm what the theory had long predicted. The interior of BPM 37093 had indeed begun to solidify. It was the first time anyone had confirmed a crystallizing core inside a white dwarf, turning a decades-old idea about how stars die into something we had actually measured. The core really is crystallizing. We had, in effect, heard a diamond the size of the moon humming from 48 light-years away. Which brings us back to that impossible price, and to why it means even less than it first appears. The value collapses for the same two reasons a metal asteroid does, only more severely. There is no technology, and nothing remotely on the horizon that could carry us across 48 light-years to reach it. With our fastest spacecraft, the ones that have already left the solar system moving at around 17 kilometers every second, the journey to Lucy would take something close to 1,000,000 years. We are not one breakthrough away from reaching it, and we are not 100 breakthroughs away. For all practical purposes, it is permanently beyond us. And even setting that aside, the whole notion of its worth rests on a category error. A diamond on Earth is precious because it is rare and small and can be cut and set into a ring. Lucy is a crushed stellar core more massive than the Sun. It could never be mined, moved, cut, or worn. Its 10 billion trillion carats are not a fortune waiting to be claimed. They are a measurement of how strange the universe becomes when you take a human idea like value and hold it up against the death of a star. Everything we call a diamond on Earth is a small, cool crystal formed over long ages under the pressure of our planet's mantle, more than 100 kilometers down. Lucy formed under a pressure and in a manner that has no earthly equivalent, from the collapsing core of a star, and it glows at a temperature of nearly 12,000 degrees, hotter than the surface of the Sun. It is a diamond that would vaporize anything that came near it, a jewel that is also a furnace. Perhaps the most humbling fact of all is that Lucy is not unique. It is simply the first crystallizing white dwarf we managed to confirm. The galaxy is quietly filling with them, because more than 90% of all the stars that have ever existed, including our own Sun, are destined to end their lives as white dwarfs. Which means the sky is slowly becoming a graveyard of diamonds, and one of those graves has our name on it. Because the most remarkable thing about Lucy is not that it exists out there in Centaurus. It is that we are looking at the future of our own star. Our Sun is a perfectly ordinary star, and it is running the same clock that Lucy already ran. In roughly 5 billion years, the Sun will exhaust its hydrogen, swell into a red giant large enough to swallow the inner planets, and then shed its outer layers into space. What will be left behind is the Sun's bare core, a white dwarf of carbon and oxygen about the size of the Earth, glowing with the last of its warmth. By then, the Earth itself will be long gone or long dead, either swallowed whole by the swelling red giant or left a scorched and airless cinder circling the shrinking ember of the star it once called home. And then, across billions of years more, that ember will do exactly what Lucy is doing now. It will cool. Its carbon will lock into crystal, and the Sun that gave this planet every sunrise, every harvest, and every living thing will slowly harden into a colossal diamond, drifting cold and dark through an empty solar system. Lucy, then, is not really a curiosity 48 light-years away. It is a mirror held up to our own future, a preview of the last chapter of the Sun's long story. The largest diamond in the universe is not a treasure. It is a tombstone, marking a star that has already died. And one day, in the unimaginably distant future, our Sun will carve one of its own. So the next time the idea of a priceless jewel comes up, it is worth remembering that the universe has already made one beyond any price a human could name, and that it did so not by hoarding wealth, but by killing a star and letting its heart freeze solid over billions of years. Lucy is worth nothing and everything at once. Nothing because no one will ever hold it, sell it, or spend it. And everything because it carries the answer to a question our species has always asked, which is what becomes of the sun and of us at the very end. That crystallized star is the shape of our own distant future, written in carbon and light, 48 light-years away. And Lucy is only one of the strange remains scattered through the galaxy. There are dead stars out there far stranger than a diamond, some so dense that a single spoonful would weigh more than a mountain, some spinning hundreds of times a second in the dark. But those are stories for another day.